So this is the presentation. I'm going to basically go through an introduction, talk about me and my company, spend more time talking about me than the company. Everyone likes to talk about themselves. Talk a little bit about what Cassandra is and why you might want to use Cassandra and maybe why not. And then talk about how and where to run Cassandra and what flavor of Cassandra to run, because there's actually lots of flavors. And then I'll talk very briefly about if you want to get started with Cassandra and you just want to kind of get an idea of what it looks like and how it feels, how to get it started on your laptop. I'll actually walk you through how to do it a couple of different ways. I've been working for Pythian for about 6 years now. We were founded in 1997. We're a global IT services company. We provide transformation services. We provide managed services for databases. We do a lot of consulting. I specifically do a lot of consulting. Up until this year, I did a fair amount of traveling. This year, obviously, that's changed. But the company as a whole has got about 360 technical people who provide support to our customers. A little bit about me. I've been loving data for more than 40 years. I've been doing Cassandra since 2010, version 0.7. I've been doing open source databases since MySQL 3.1 in 2004. I personally am addicted to reading anything and everything. I can't go to bed at night without reading. I have to read something. I'm a traveler. I love traveling. I've been doing it all my career. When I was young, people used to tell me you get sick of it. I never have. I still love it. I'm feeling kind of frustrated right now because I can't. I'm a hiker, not your weak hiker. I don't go out and hang out and camp in tents and stuff like that, but I like to go to natural places and kind of stay there for a few hours. I'm pretty much a day hiker. And I've been a geek almost from before the word existed. I've worked on tape files, raw disks, ISAM, Codicil network databases, IBM IMS, more flavors of SQL than I can remember. I actually met Cod and Date once in the late 1980s at a seminar. I seriously doubt they would ever remember me, but I did actually meet them and shook their hands. I've also worked on several flavors of NoSQL, including MongoDB, Cassandra, React, Couchbase, and CouchDB. Those are actually different. Some of my favorite computers, the very first one on the left is a Digicomp 2. My mother gave that to me when I was 12 years old. It's basically a marble-operated flip-flop computer, and it was actually a lot of fun to learn the basics of how computers worked. The rest of them around there are various computers I've worked on over the years. The Sinclair, CX80, an IBM 360, an IBM 1620, Tandem Systems, an Apple II, and the thing in the middle is my latest computer. It's a Raspberry Pi 4, 4B with 4 gigs of RAM. I think it's really actually pretty cool device. And of course, since I like data, these are some of my favorite storage devices. The thing here, and the tape here is actually a duct tape, which is, as far as I know, the only random access tape ever built. You actually can access it as a block device, reading and writing individual blocks on it. I've made a lot of use over the years of the old 3M floppy disks. This one's an 8-inch disk. The big thing in the middle there with the lady standing next to it, to give you an idea of the size, that's an UNIVAC FastRAN. It's 10 feet long by almost 5 feet tall, and stored a whole 200 megabytes. This is back in the 1960s and early 1970s. The thing above it is an IBM 2314, disk drive, which stores a little over 100 megabytes, if I remember correctly. Considerably smaller and obviously newer generation. The other two The crucial is a 2 terabyte SSD that I just bought to provide some real disk space for my Pi. And the thing down at the bottom right-hand corner is an M2 SSD. That's a 1 terabyte device. So typical of what people are seeing in their laptops these days. That essentially is the disk drive these days. I think these are kind of cool devices. I'm fond of hardware. Now, on to this real topic here. What is Cassandra and why? Why would you use it? What is Cassandra? First of all, what actually is it? It's a distributed database. It works within a data center location. It also works geographically. So you can have a Cassandra cluster that spans the world, or you can have a Cassandra cluster that lives on a single machine. In practice, you want it to be on at least multiple machines for high availability, if nothing else. It's designed for incredibly high traffic volumes, especially writes. Everything from the ground up was all focused on handling incredibly high write volumes. It's designed to linearly scale, and I say that with serious caveats. You have to understand the way it was designed, and you have to understand how you need to model data with it. Otherwise, its linear scaling will go out the window. It's designed for high availability from the ground up. Literally from day one, it was going to be high availability. They said, we don't want masters, we don't want slaves, just nodes. And that's how it works. Every node is equal. There is no master, there's nobody in charge. It's eventually consistent between nodes. This allows it to be a lot of the other things it is, but it also makes life interesting for programmers. What that means is I write to a node and the data is there and it will get eventually to the other nodes in the cluster. But if I go to read another node thinking that data will be there, like in the next few milliseconds, it probably won't be. So you need to be aware of the fact that data doesn't always get spread throughout the cluster instantaneously. Architecturally, Cassandra is based on the Amazon Dynamo and Google Bigtable white papers that were written in the early 2000s. Much of the Google Bigtable features have been hidden and are no longer really available, but the underlying architecture still exists that way. I hear people say it's a column store, and yeah, it is. But these days, when people think of column stores, they think of things like Google Bigtable, Google BigQuery, and Vertica, and a bunch of other things like that. And Cassandra is not one of those. Cassandra is not designed for doing analytics. It's not a massive parallel processing engine, but it stores data using column store technology. It's just convenient for it to do it that way. It's not that it's really a column store in the modern sense. It stores data in log structured merge trees, which is typical of databases that want to be able to handle high write volumes. It uses an SQL-like language called the Cassandra Query Language, CQL, but it is not SQL. It's important to recognize that while the language looks like SQL, while it kind of looks like a relational database, it is not. This is kind of a picture of what Cassandra looks like it in a geographically distributed way. You have an application that can talk to any particular node, doesn't really matter which one. I shouldn't say that the driver actually is pretty smart. Not every node has every other node's data, but every node knows where every other node's data is, and the app drivers do as well. So if an app is making a request, he will usually send the request to a node that actually has at least some of the data that's being requested. But beyond that, it can send it to pretty much any node. That node will then essentially act temporarily as a master. It's called a coordinator, and it coordinates traffic between the nodes. What Cassandra isn't, I mentioned this already, but it's important to remember it. It's not relational. Yes, you can attach Spark to it and do joins, but that's not really going to make it a relational database. That just gives you the ability to do some reporting, things like that. It's just not a relational database. If you need joins, if you need a lot of the things that go with relational databases, you don't probably want Cassandra. It has very limited aggregates. There's a good reason for that. The idea behind Cassandra is high volume traffic. Aggregates can be expensive, so they are very limited. There are very limited where clauses, same reason. Complex where clauses can slow things down, so you're not allowed to do those. There's no referential anything. That includes joins, referential integrity, any of that kind of stuff. Back to, it's not relational. There are no transactions. Yes, there are some vaguely transaction-like features, but they are not transactions. And more importantly, they actually are not a particularly good idea to use because they impact Cassandra's performance. So don't think in terms of transactions. If you need transactions, you need ACID, you don't want Cassandra. No locks. You can implement them yourself in Cassandra. I have seen, I don't know how many customers do that, and they always regret it. Don't do it. If you want a lock, you can create a lock somewhere else. If you need lock that's kind of integral to the application, maybe you don't want Cassandra. I know I'm making it sound horrible, like, what would you ever use Cassandra for? Well, here's some examples. What would you use it for? Well, wherever writes exceed reads by a very, very large margin, we're talking 100 or more to 1, that sort of thing, where you know your query patterns well, and they're not likely to change frequently. Because this is not a relational database, you're not going to be able to do kind of joins and stuff like that. You need to kind of just know what your query patterns are going to be, and they're going to be fixed. Your traffic volumes will vary a traditional relational database. We have one customer, they actually break the rule about reads. They do somewhere in the neighborhood of 9 million reads a second at peak. Although their write volume for that particular database is a few hundred a second. Most of them are the other way around. It's they're going to be receiving millions of writes per second, but they're only going to be doing reads in the hundreds or thousands per second. Some common examples of where Cassandra is frequently used: advertising tracking hit rates, people sending in, I shouldn't say people, applications sending in ad hits, ad conversions, things like that. All that gets dumped into Cassandra, and then a process will read every few seconds. Will read and create a dashboard from it. Sometimes writing it back to Cassandra, sometimes writing it somewhere else. It's not that you can't read a lot of data in Cassandra, but your reads shouldn't be a high volume. It should be moderate volumes of reads, high volumes of writes. IoT raw data capture. It's used a lot in the IoT industry. If you have a lot of devices, meters, automotive stuff, the automotive industry uses Cassandra a lot. Not the health industry, the fitness industry uses Cassandra a lot for collecting data from fitness devices. Customer service applications. Actually, several of the larger phone companies in North America use Cassandra for their customer service. They basically store Cassandra customer billing information, which is basically read-only. It's written once, and then occasionally customers go to it and want to find things. But again, heavy writes, relatively light reads. Internet usage tracking, another kind of thing like that. Application metrics collection. A number of the companies that provide metrics collection for other companies that provide it as a service use Cassandra as a database. Weather data, actually, the Weather Channel uses Cassandra. So I hope that kind of gives people an idea of what kinds of things, where Cassandra is useful. If you're still thinking about Cassandra, the worst thing you can do is build a poor data model. So the very first thing you want to do is go to the Datastax Academy and take their basic initials classes, their 100 and 200 level courses. They will very, very much help you to understand how to design your database for Cassandra. If you want to don't want to have to go through a video class for a really quick overview, this is relatively new. The Apache Cassandra organization has put out a doc on data modeling. It's not nearly as complete as the Datastax Academy, and I strongly recommend the Academy, but it'll give you an idea. It's really important that you design your database correctly. If you do, Cassandra will work wonderfully for you. If you don't, it will behave badly. Now, this is true of every database. Badly designed data models produce badly performing databases. But with Cassandra, it's especially true. So, how and where to run Cassandra? Now that we've talked about, what it is and why you might want to use it. The first thing you need to do is think about, what are your plans? Where are you in your plans for Cassandra? What are you trying to do? Are you planning to play with it? Learn a little bit about it? Are you planning on developing a Cassandra application? Are you planning to deploy it to production? Where do you want to run Cassandra? Are you going to try and run it in the cloud? Do you have a data center you want to run it in? Are you thinking about running it on your laptop, which is good for experiments and development? You're looking for an integration test small cluster on dedicated VMs or containers? Yes, Cassandra can run in containers. In fact, that's the big thing these days. Everybody's talking about running in containers. I personally have some reservations about that. Not containers per se, containers are just fine, but most people, when they think containers, they also think about things like Kubernetes, and Kubernetes is designed from the ground up to run stateless applications, which are ephemeral, and Cassandra nodes are not stateless and they're not ephemeral. Using a tool which is designed to do that, ephemeral and stateless things for running state things, makes me a little nervous. All that said and done, it's become quite popular. You got to run production. You want to use VMs, containers, raw hardware, or Cassandra as a service. There's lots of choices there. What Cassandra distribution / version are you interested in? There are a bunch. For what I think of as a niche database, there's an amazing number of options for you to choose from. To start with, there's good old Apache Cassandra. Its current release is 3.11. It's in beta for 4.0. Everybody's excited about 4, including me, but it's not out yet. Datastax Enterprise, their current release is 6.8. The Cassandra API compatible upstarts. These are not Cassandra, but they look like Cassandra. You can actually issue CQL commands just like you would to Cassandra, uses the same drivers, but they're not actually Cassandra under the covers. Probably the biggest and most popular one in that area is Scylla. There's 2 versions of that, the open source one and the enterprise one. There's a company called Yugabyte. I don't know how many people have heard of that, but it actually, Yugabyte kind of looks like Google Spanner or Cockroach, but it also has a YQL API call, which looks basically like CQL. Actually, it's identical to CQL. And Microsoft CosmosDB. It's a multimodal database. Does SQL. It does MongoDB, and it does Cassandra. I'm really not sure how many people are actually using it for Cassandra, but it's there and it's available. Then there's Amazon Keyspaces that was just released. It's based on Apache Cassandra 3, but there's a little bit more to that story. Then there's the mashups. Probably the most popular of which is called Alessandra. It's a mashup of Elasticsearch and Cassandra. And I'll talk a little bit more in detail about each one of those. The original twins, Apache Cassandra is open source. It's written in Java. The fact that it's written in Java somewhat limits hardware scalability in many ways by the Java heap. As a result, when you're running Apache Cassandra, you're going to find yourself using moderate-sized VMs or instances, and if you have a lot of traffic, you're going to have a lot of them. It's not uncommon to have hundreds of nodes in your Cassandra cluster. Datastax Enterprise, they have added extensive additional features, which of course come for the price. This is not open source. It includes Spark support, although they just actually released the Spark support, their Spark drivers and support into the open source, which I thought was interesting. Solar indexes, which gives the Cassandra the ability to have a full text search, and graph capability. It gives Cassandra the ability to do graph. They've been struggling with that. Graph, by its very nature, tends to concentrate things, and Cassandra is all about trying to distribute things, and the two kind of come into conflict at times. Also, as of DSE6, Datastax Enterprises uses a significantly different code base, which I'll talk about in a minute. Scylla. Scylla was designed by the same team that built the KVM virtual machine. It's written in C, C++. It uses the Cassandra 3.x on-disk database format, but it's obviously the code base is completely different. It supports the basic CQL features, but with some differences. They never implemented Cassandra's local secondary indexes. That's not a big loss. Pretty much every time I see people using Cassandra secondary indexes, I tell them they shouldn't. But instead, what they implemented was a global secondary index that has some performance considerations, but it's actually a much more useful feature. They claim that their materialized views actually work. In Cassandra 3, they announced a concept called materialized view, which is essentially a globalized secondary index and view combination. Unfortunately, in Cassandra, it doesn't work. Still doesn't work in 4, and doesn't work even in Datastax Enterprise 6. Everybody basically says don't use them. Scylla claims theirs works. I haven't enough knowledge to assess whether that's true or not. They also offer their product is a multimodal database, and they offer a DynamoDB API. I guess it kind of makes sense in that Cassandra was originally based on, in large part, on DynamoDB, that they would go back to the root of that and say, okay, fine, we'll provide that API as well. Scylla uses a threading model, which is allows them to effectively use much larger machines than Cassandra can. What they do is, instead of having a thread to do everything, every task that's going on has a separate thread, which can result in literally thousands of threads. It's not uncommon to see a Cassandra node running 10, 20, 30,000 threads. They run one thread per CPU, and they manage the dispatching internally within that thread. It's a lot of work. It's kind of like OS kind of level work, but they've actually done it. It's allowed them to really effectively use much larger machines, because instead of wasting a lot of overhead on thread switching, they've minimized that. Datastax looked at what they did and said, hey, that's really cool. And they added that threading model for DSE6, which is what has made the Datastax code base very different from Cassandra Apache. Whether or not they'll ever release that to the open source, I don't know. It's really made a big difference. They've been able to double or triple the size of their of each individual node. They still can't get as large as Scylla because they still have the Java heap, which still gets in their way. Scylla is available to run anywhere in or out of the cloud, much like the Twins. Yugabyte. Architecturally, it's much closer in design to CockroachDB and Google Spanner. It is fully consistent. So you don't have the eventually consistent issues that people struggle with sometimes in Cassandra. It's not compatible on disk, unlike Scylla, which basically hews to the Cassandra format. It still uses Gossip. It still does a lot of things very similar to Cassandra. Yugabyte only supports CQL. It's under the covers totally different. It's wire compatible with Cassandra 3X. You can take an application that worked with Cassandra yesterday and plug it into Yugabyte and it will work. I've had a number of customers experiment with Yugabyte. I had one customer who actually decided they preferred it. It also has the advantage that it supports Postgres as well. The Postgres dialect. It's not Postgres, of course. And it also is available to run pretty much anywhere in and out of the cloud. Architecturally, it's a little more complex than Cassandra, but it's still pretty straightforward to set up and run. It does not have the user base that regular Cassandra and Scylla have. It's a smaller community. I'm going to cover these two together, CosmosDB and Amazon Keyspaces. Microsoft decided a few years ago to come up with a database that satisfied everybody's needs. They called it CosmosDB. It runs really only in the Azure cloud. You can get an emulator that you can run on your laptop or something like that. But if you want to run a production workload, you really have to do it inside the Azure cloud. It currently supports MongoDB, Cassandra, and SQL APIs. There may be more that I'm not aware of, but those are what it currently supports. I don't currently know anyone using the Cassandra API for CosmosDB. I've experimented with it a little bit myself, and it's functional. And it performed reasonably well. I haven't actually run across a customer yet who uses it. Amazon Keyspaces is brand new. It was just released into general availability a few days ago. It runs in AWS only, obviously. It's based on Apache Cassandra 3, but as is typical of Amazon, they claim they've mucked around with the back end, and instead of using Cassandra's traditional log structured merge trees, they're using a backend store based on DynamoDB. I've done a little bit of playing with it. It doesn't currently have support for the geographic distribution that Cassandra does. It's missing some of the features that are typical in Cassandra, but they're ones that you should probably use anyways. It's a basic functionality where it's there, and it seems to work reasonably well. And finally, we have Alessandra. Basically, this is a mashup of Cassandra and Elasticsearch. They've been kind of glued together. Cassandra version 2 and Cassandra version 3 have been set up to work with Alessandra. There is a website dedicated to it. If you're interested in getting full text search into your Cassandra working together, then Alessandra is something you might want to consider. It's architecturally a bit messy because you've taken two distributed database technologies and mixed them together. They're both written in Java, so that kind of helps, I think. But architecturally, they're very different. They're both open source, and with the Elasticsearch, you get basically a global indexing feature, which is also, because Cassandra, like I've mentioned earlier, Cassandra secondary indexes by default are local only. They are of limited value. Having a global index has its uses, and that alone makes Elasticsearch and Alessandra interesting. I've worked with a number of companies that have used Alessandra successfully. So, where to run and or use Cassandra? You've decided you want to use what particular version you want. I don't care which one. If it's really high volume, you might want to be thinking Scylla because you can probably use less servers for it, a less complex environment. If you typically want the most functionality in terms of capabilities, you may want to stick with traditional Cassandra. Um, anyways, do you want to run it as a database as a service on one of the cloud vendors? There's some real traction to that because it's nice and easy. It's straightforward. You don't have to do anything. Um, do you want to run it in the cloud at the hardware platform level? In other words, like AWS EC2 or GCP's GCE. I don't remember what Azure calls it, but where you're basically just running VMs. Do you want to run in a regular data center under VMware or other cloudish software? Do you want to run it on hardware? Do you want to run it in containers using Kubernetes, DCOS, or Docker Swarm? I don't recommend using containers unless you're going to use one of the other technologies. Finally, do you want to run on your laptop, desktop, or your favorite Raspberry Pi? Yes, 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 it runs on Raspberry Pis. The two pictures on this page are actually clusters of Raspberry Pis running Cassandra. One of them is at the Datastax headquarters. I don't know if it's still there, but they had it there for several years. They actually had that up and running in 2015 or 2014. So it's been running on the very small original Raspberry Pis. And the one over on the other side, I just really like that picture. That is actually a Cassandra cluster running in what looks like a typical system rack, but that particular system rack is actually made from Legos. So what looks like giant cables are actually just standard Ethernet cables there. It's really kind of cool. So database as a service options. Realistically, today, if I'm going to start using Cassandra, I would seriously consider doing it database as a service. It's just makes very little sense to do it any other way. Instacluster is the original Cassandra as a service company. They've been in business since 2014, I think. And they run on AWS and GCP, and they run either Datastax Enterprise or Apache Cassandra. You can take your choice. Datastax Astra. Datastax has been playing around with the idea of running their own cloud for several years. They've made several attempts. None went anywhere. Astra is their latest. They just released it into GA. It runs on AWS and GCP. The original plan was to also include Azure, so they probably will include Azure in the future. The thing that's really cool about Astra is you can have a Cassandra cluster that runs on AWS and GCP at the same time. So some of your nodes are running in AWS, some of them are running in GCP. It's DSE only, which kind of makes sense, although they point out that you can run anything you can run in DSE, you can run in Apache, because DSE is a superset. So they strongly encourage people to use it. Amazon Keyspaces, that's also brand new. It obviously only runs in AWS. Scylla Cloud, it runs in, or Scylla, it runs in GCP and AWS. And actually also like Astra, you can run your cluster split between the two if you want. IBM Compose for Scylla, it runs in the IBM cloud and it's Scylla Enterprise. Yugabyte Cloud runs in AWS only, so far as I know, and it offers the Yugabyte version. And obviously Cosmos is available running Azure. There are others as well. There's actually several others, but I didn't want to put any more. They wouldn't really fit on the slide. These are the main ones. So what does it get you to run database as a service? Well, you get an instant cluster. You just fill in a few parameters and push a button. Or you can even terraform it. It gets you automatic backups. It can get you automatic repairs. Repairs are very important in Cassandra, and it's part of how Cassandra maintains consistency over time. The eventual consistency thing means that there's no guarantee that you've done it right, that it will actually propagate anytime soon. Repairs sometimes are needed to kind of finish that job. So repairs is something you do need to run, and they're a pain in the you-know-what to run, and they don't always work right. Have your database as a service people who have lots of experience doing that do it instead for you. That's a really good idea. It avoids you from having to deal with that. Automatic version upgrades. Now, Cassandra updates, especially minor version updates, are really not hard. In fact, one of the nice things I like about Cassandra is the notion of taking a node down or taking a cluster down for any reason is just anathema to Cassandra. There's never a reason to take a cluster down. There's always ways around that. And in fact, mostly it's built right in. You want to upgrade a node, you take one node offline, you update it, bring it back in line, and go to the next one. If the database format has changed, there's tools that you run that basically, while the applications are running and everything's going, it will basically update that. Major version updates, same thing. It will do that for you, but usually not automatically. You usually have to say, pick when you want to do that. Built-in log aggregation. Cassandra, because it runs on lots of nodes and because the log tends to be noisy, people tend to ignore it. That's a really bad idea because a lot of really useful information goes into the Cassandra log. I mean, I've been working with MySQL for many years, and most of the time the MySQL log is very quiet, and the rare occasions when something's in there, just the fact that something got written into it is usually enough to cause you to want to go look at it. Although I've seen people who've ignored the log and to their own regret. But in Cassandra, it's difficult to even figure out what's going on in the log. A log aggregator, which allows you to aggregate all of the nodes together and then sift through it, is something you really want to have. That's built in typically with the database as a service Cassandra offerings. It also comes with built-in monitoring. If you want to have a high availability database, you really want that high availability database to be monitored. You want to make sure that it's running. You want to make sure nodes are working. If you don't do that, I would argue that you're really not serious about running high availability. Excuse me. Well, we've talked about all the reasons why you should run one of the Cassandra as a services, but you decided you don't want to for any reason, for any one of a whole bunch of reasons. If that's the case, these are the things you want to be aware of and you want to think about. You want to use automation to build your clusters. Do not try to manually create a cluster one node at a time. It's a really, really, really bad idea. There's all kinds of really great tools. Use them. I don't care if you use Chef, Puppet, Ansible, SaltStack, Terraform. You want to use containers. I've already talked about my concerns about using containers, but if you're going to use containers, use the containers, use Kubernetes, Docker Swarm, DCOS, your choice. But use something. Don't try and configure and run them individually. It's a really bad idea. You want all your nodes to be running the same thing. You want to have control over and knowledge of what's running on all your nodes. Use a log aggregator. There's a couple of really nice ones out there. And lots more. If you into the open source world, Elk is great. That's Elasticsearch, Logstash, and Kibana. That's why they call it Elk. And your Elasticsearch people will be more than happy to give you an enterprise version if you want, but it's also available in the open source. I personally love Splunk. I think Splunk is a great tool. It's also god-awful expensive, and most people look at it and say, nah, too much money for me. But if you can afford it, it's great. Also, monitor the cluster in the real time. If you're running Datastax Enterprise Edition, there is absolutely no reason on earth you shouldn't be running Ops Center. And Scylla offers a set of operations tools. Again, unfortunately, most of their tools are enterprise. but they offer some of their tools in open source, so you should take advantage of it if you can. Failing those kinds of things, you should be running Prometheus with Grafana. There's some really good standardized Grafana dashboards, and Prometheus is a really good tool for managing the database behind Grafana. So these are things you really want to do. It's critical. Finally, whatever you want to do, whatever you do, is don't do this or do this. Do not run a single node for development and testing. It's a really, really bad idea. This kind of goes back to when you're testing, you should be testing in an environment that's going to behave similar to what production will. And the more similar you can get, the better. Cassandra running as a single node, you can run it. You can just bring up a single node, it'll work. But when you're running it as a single node, all of the interactions that go on between the nodes, they aren't there. And if you don't understand how those interactions are going to affect your development and affect how your application is going to perform, you're not going to be happy when you try and put it into production. So you should run a cluster of at least n nodes where n equals your replication factor. I always argue it should be a little bit more than that, but at least n. And by default, pretty much everyone tells you should run at replication factor 3. You can run more. That's some special cases where it's handy, but overall not such a great idea. But you should never run less unless you have a really good argument for it. I've seen a few arguments for it, but in practice, there's very good reasons, and I'm not going to go to them here because I could spend another hour just talking about that. Replication factor should always be at least 3. And finally, again, use automation tools to deploy your Cassandra. Use ACM tools like Puppet, Chef, Ansible, Salt, etc. Use container tools like Kubernetes, Docker Swarm, etc. Run Cassandra as a service, and this is the first time I'm going to mention this, but it's actually cool for development only. There's a tool called Cassandra Cluster Manager. It makes starting a Cassandra cluster on your local laptop or desktop or Raspberry Pi just as easy as using the Cassandra as a service on a cloud. It's literally almost just about push button. In fact, I'm going to demonstrate it because I really love it. If you're also if you're running Cassandra as an operations person and you want to kind of get an idea of how configuration changes might affect things, or what does the new version of Cassandra look like, it's so quick and easy to bring up a new version and play with it. CCM is really nice. So you want to run it on your desktop or your laptop or a Pi. Yeah, I like Pis. You only want to do this for development, please. You still want to run a cluster. Yes, you still want to run a cluster. Yes, you really want to run a cluster. It's really important to understand that running a single node is a bad idea. Node should always equal replication factor or replication factor plus. So if your replication factor is 3, which is pretty common, then you should have at least equal 3 nodes or maybe 4. You can manually install it 3 times. It's a lot of work, especially if you're doing it for the first time. You won't understand what you're doing for a while, and it'll be a challenge. You'll spend many hours. It's a bad idea. It'll make you feel bad. You'll feel like Cassandra's a pain in the, you know what, you don't want to use it. It's awful. Back when I first started working with Cassandra, we didn't have any of these tools. And yes, I did it by hand. And yes, I hated it. It seemed so hard. It was like, wow, this is hard. The tools make it so much easier. Now, the ways you want to do it today, you can start some containers. That is actually really easy. Yes, you can even do that on your Raspberry Pi. Or you can use Cassandra Cluster Manager. And I'm going to show an example of both of those next. Doing it with containers, make sure Docker's installed and running. Start your first container, basically Docker run -d, which means it's going to run in the background as a daemon. Give it a name, use the word Cassandra, The Docker archives know that that means you're going to get the latest version of Cassandra, which is going to be Cassandra 3.11 right now. Once you've done that, verify your container is up and running. Do a Docker exec, your Cassandra, your container name, and node tool status. And I'll show you on the next screen, somewhere along the next screen. Sorry, one of the next slides. I'll show you actually what that output would look like. Then start your next node with the first is seed. So it'll be doctor, run, name, and then you're going to have to specify the seed. And you'll get that out. You'll get this number right here from. You get this number right here from when you did the node tool status. So you want to give that as a seed, which basically tells it what other container to connect to. Then basically you should start your next one. In between, you probably want to make sure the second one's coming up. You can only start one node at a time. If you try and start more, they will fail. Each one has to connect before you can start the next one. But you got all three up and running now. You verify the containers are running, verify that the cluster is running, do the Docker, exe, whichever node you want, node tool status. Then you can start the Cassandra shell, Docker, exe, cas3, 2 or 1, whichever one you want, cqlsh, and you can basically type in CQL commands. Like I said before, they look a lot like SQL. Then you can stress the cluster if you want. There's a tool built into Cassandra, and it actually is included in the Docker container that comes with, that you can get for Cassandra. So you can actually have it do something without having to actually write any code. You can actually say, yeah, I can actually make this thing do something. These are the steps, and it's relatively straightforward. I've done this, I don't know, probably a couple dozen times. I can do it in about 5 minutes. It doesn't take long. The other one is to do it with CCM. CCM is written in Python, so you install it with pip. Boy, am I glad pip 2 or Python 2 is dead. You no longer have to worry about pip 2 and pip 3 and where it's going to be installed. Now you can just say pip install, and it installs in your Python 3 environment, and it's really cool. Once you've installed it, you create your first cluster. Type in CCM create, N3 was node 3, vnodes. Vnodes is one of the configuration parameters that makes adding more nodes much easier. Tell it what version you want and give it a name. Then it basically creates it, starts it up. Well, actually, this did not start it up. This because I didn't do the S. So this doesn't start it, but it created it. You can list your clusters. You'll now see your new cluster. You'll now see your new cluster there. You start your cluster with typing in CCM start. Check the status of your cluster. CCM node, whichever one you want. There'll be node 1, 2, and 3. Node tool status, and you'll see the node tool output, much like you would have with containers. Use CQLSH to access your cluster. CCM node 1, 2, or 3, CQLSH. And you want to stress your cluster, you do CCM stress. Notice this is a much smaller list of commands. This takes even less than 5 minutes. And it's easier to manage. You don't have to manage each individual node. You could also bring up Kubernetes and run it locally as a Kubernetes cluster. But that seems like overkill for running on your own laptop. Here's an example of actually running the CCM operation. First thing here, you see the CCM create. Here I use the -s option, so it would start it right away. I do CCM status, which shows me that I have the nodes up. Then I do a CCM node tools status, and you can see I have a cluster running with 3 nodes in it. The IP addresses are the local host. Before I started using CCM, I had never known this, but when you use localhost, localhost can be more than just 127.0.0.1. In Linux, You can do anything from .1 through .255, or 254, I'm sorry, .254, and use all of those IP addresses just fine. And it's just automatic in Linux. If you're running on a Mac, you actually have to run a tool to create them, but on Linux, it's there automatically. Then you can use CCM to access your first node or whichever node you want. You can get into CQLSH. I just did a single command here, describe Keyspaces, and it lists the system Keyspaces. Those are there by default. A Keyspace, think of it, a Keyspace is sort of like a database, a logical database. When you create your own application, you're going to create one of these. Exit out of there, and then you saw the CCM list before, and you can see here I've got a bunch of clusters here. You can only have one running at a time, and the one that's running is obviously the one with the star. And the output, that CCM stress write, the output from that is voluminous, to put it simply. It's just huge. But this is the results I got from that run with the largest number of the best number of threads. I shouldn't say the largest, the best number of threads. I was running 56,000 writes per second. This is on a laptop, nothing special. The mean latency was 15.9 milliseconds. That's actually slow for Cassandra. Cassandra, unlike most databases where writes are more expensive than reads, and Cassandra writes are cheaper than reads by an order of magnitude. It's not uncommon to see writes taking less than a millisecond. If you're looking at it on the local node where the write's actually taking place, it's usually a few hundred microseconds. Reads are typically in the low milliseconds. The median latency here is 6.3 milliseconds. The 99th percentile, now this is really stressing, I was working it hard, got me up to 200 some milliseconds. But even at the worst was like 373 milliseconds. And this is doing 1.6 million partitions. Think of that as rows. So it was actually a fair amount of workload that I was stressing on there. Okay, talk about the Docker. Okay, Docker, do the same sort of thing. You do Docker run name of the thing and Cassandra. If I was doing it for the first time, it would generate a whole bunch of output, downloading the version of Cassandra and all the pieces of the container. If you're familiar with Docker, you've seen that before. Since I'd already done that, all you got here was the Docker container ID, this big number. Then you do a node tool status, and you can see I've got one node up and running. And it tells you here, this is the node IP address, which I'm going to be able to use in the next one. So I do another one, use the Cassandras, and I do a node tool status there. And now I notice I see I have two nodes, but one's joining. You need to wait until these both say UN instead of one saying UJ, before you want to go to the next step. The next one, you do the next node, same thing. This time you get basically all three of them up and running. You can do a CQLSH. I didn't do a stress, but stress, by the way, is included in the Docker container. Conclusions. I'll do this quick because we're running out of time. High traffic rates, writes over reads. Static query patterns. You don't want your query patterns to change a lot because with Cassandra, it's a bit of a challenge to make changes like that. You don't need any relational crap. Eventual consistency is okay. If those things are true, then you can say, fine, let's go for it. What Cassandra version do you want to use? Do you want to use one of the original twins? Do you want to use an API compatible thingy? Do you want to be able to do Postgres to it as well as Cassandra thingies to it? Then maybe you want Yugabyte. Do you want to be able to do it the smallest number of physical hardware nodes, you might want to look at Scylla. Do you want to be able to do full text queries? You want to look at Datastax Enterprise with Solar, or which is essentially that mashup that Cassandra is, or you want to run Cassandra. Those are kind of like the things you want to think about. Where do you want to run it? You're going to run it in the cloud. You're going to use database as a service. If you don't use database as a service, you're going to want to use HCM tools. You really do. You really do. On your laptop or desktop, do you want to use containers? Do you want to use Cluster Manager? You can manually do it. Please don't. It's hard work. We just got a new guy up to speed on Cassandra. He's a MySQL guru, and he insisted on doing it manually. It took him 3 days to figure it out, after which I demonstrated it to him using CCM, and he said, that's cool, but I learned a lot in those 3 days. He's right, but most people don't need to learn that. And yes, you can run it on a Pi. Here's some really cool logos from the various places. CosmosDB, Scylla, Azure, Yugabyte, good old Cassandra, the little I there, Datastax Enterprise, Yugabyte on the cloud, InstaCluster. And that's it. Any questions?
I did not see any questions come in, John. Let me just double check. No, I didn't, but we have a couple minutes. And so I had a quick question for you.
Sure.
And so, you've mentioned there's a plethora of options, right, for running Cassandra. What do you see as the most common configuration?
What do you mean?
So, you've deployed this numerous times. Do most people just elect to use the open source Apache and kind of roll their own on like EC2 instances? Do they now choose one of the cloud providers? Like what tends to be the more prevalent, installation method or setup?
From my experience, most people choose to run on their own.
Okay.
Up until recently, InstaCluster was kind of like the only one that was doing the as a cloud as a Cassandra as a service. Sorry, Cassandra as a service. And a lot of our customers are price sensitive. The vast majority of them are running in the cloud. The vast majority of them are running on AWS. We have a few in GCP, and we've had a couple on Azure. We have a surprising number that are actually running on their own, inside their own data centers and VMs still. And it always blows my mind when I see that. It's like, why are you guys doing that?
All right, great. And so, John, I don't know if you're on the Slack, but there's a couple other questions that just came in, but we've got to move to our next speaker. So I do appreciate, John, you taking the time to walk us through that. Very informative. I know that I'm not a Cassandra expert. I learned quite a bit during that as well. So really appreciate your time.